everyone, how are you all? I'm Dr. Nandita and today in this live session I would like to welcome all of you to Aptdemy. I'm here today to solve some problems of on a chapter of organic chemistry and which you have learned in the chapter alcohols, phenols and ethers. But before I start, I would like to share some information with you. On coming Sunday, that is 18th of June, we are organizing free demo classes on physics, chemistry, and mathematics. So these classes should be geared on CBSE, ISC, other boards, and IIT examination standard. If you are interested, you can send us email or you can comment below. These classes should be conducted in our Laketown Aptdemy branch, and details regarding these classes you can find in our description box. So I hope to see you all on 18th of June Sunday. Now let's get started with our main topic. But before I start to solve the problems, let me just talk a little bit about the classes of compounds that are going to be covered in this lecture. So what are alcohols, phenols and ethers? You already have learned, but little bit recap, right? So you have heard about substitution reaction, right? So what is the substitution reaction? In any hydrocarbon, if one hydrogen is getting replaced by either one atom or group of atoms, then you know that substitution reaction takes place and a completely new compound is generated with completely different properties as well as different applications. Now, alcohols and phenols are generated if from one aliphatic hydrocarbon, one hydrogen is getting replaced by hydroxyl group, that is OH group, and phenols are generated if from any aromatic hydrocarbon, one hydrogen is replaced by any hydroxyl group. So, alcohols and phenols, these are very important class of compounds. So these compounds find application not only in industrial aspect, but they find application in our day-to-day life. Now I'm going to share some of them. So basically, if you have heard about the simple spirit which we are basically using to paint our wooden furniture, this is a compound made up of hydroxyl group. The sugar we eat, the cotton we are using for making our fabrics, and these kind of things, and also the papers that we are writing, we are using to write down something, that all are made up of compounds containing hydroxyl groups. Just imagine your day without paper. You don't have any books, you don't have any notebooks, we don't have any currency notes, checks, newspapers, and also the interesting magazines that contain interesting pictures as well as very interesting stories. So we would have been landed in a different world. So you can easily imagine that these classes of compounds, alcohols and phenols, how important are they? Now, alcohols and phenols are generated or contain one or more hydroxyl group which is directly connected to carbon atom of either aliphatic hydrocarbon or aromatic hydrocarbon respectively. And ethers is a different class of compounds which can be generated if you replacing one hydrogen from one hydrocarbon by alkoxy group or aryl oxy group. Let me just quickly uh, draw some structure for you, very simple ones. So if you consider alcohols, I will write an example as methane. So from methane, that is CH4, one hydrogen has been replaced by this hydroxyl group and methanol has been generated. Right? Now if you consider phenols, from one aromatic hydrocarbon, one hydrogen is getting replaced by hydroxyl group. This is our phenol. And for ethers, we can write, because I have already mentioned that one hydrogen can be replaced by alkoxy group, that is OR, we can consider, or it can be, if you consider benzene ring, then CH3. So OR or OAR. AR means aromatic group. So if one hydrogen is getting replaced by OR or OAR, that is alkoxy or arioxy group, ether kind of compounds are generated. So I hope you are now introduced well with the compounds that we are going to cover here. Now let's get started with the problems. Now this problem number 1, appeared in the Joint Entrance Advanced Examination 2022. This is a very interesting kind of problem where not only the organic compound is, that is alcohol here, is involved, but also this problem contains some concept that you have learned in the inorganic chapter of atomic structure. So let's get started. Problem 1 is saying consider the following reaction. This reaction has been given. Now, on estimation of bromine in 1 gram of R, using Carrier's method, the amount of AgBr formed in gram we have to calculate. Atomic masses of hydrogen, carbon, oxygen, phosphorus, bromine and silver has been given. So here they are considering R as the major product. So first we have to understand the equation, or we have to get the product. So because red phosphorus is reacting with bromine, so we can write 2P plus 3Br2. This will generate 2PBr3. Right. Now I am writing or drawing the given alcohol, that is this one. This also contains a bromine group. Now, if it reacts with the generated PBr3, 3 moles of this compound will react, and this will give you the R that we have already introduced, or I'm just writing down the structure of R after the reaction. So this is basically the reaction product, that is this one. This is our R, or we can consider as our major product, as has been given. Right? And H3PO3, right? Now, as we have come to know the structure of R, that is the major product, from this one, we need to apply the laws or concept that we have learned in atomic structure to solve the rest of the problem. So it is given that the mass of R is 1 gram. So we can write it down. So mass of the major product R is given as 1 gram. From here, from the given atomic masses, we can easily calculate, or from the given structure, we can easily calculate the molar mass of R. So the molar mass of R, if you consider the structure, you can see there are 2 bromine atoms. So and the atomic mass of bromine is given as 80. So 2 times 80 for bromine plus there are, if you consider the structure of R, there are 7 carbon atoms. So 7 times 12, which is the atomic mass of carbon, and there are 6 hydrogen atoms. So 6 times 1. 1 is the atomic mass of hydrogen. So if you calculate the molar mass of R, will come out as 250 gram per mole. Right. Now, from the structure, you can easily see that 1 mole of R, and from here, as molar mass of R has been calculated as 250 gram per mole, we can easily calculate the moles of R or number of moles of R. So what is the formula? Weight of R or mass of R divided by the molar mass of R. So this is equal to, mass of R has been given as 1 gram and molar mass of R is 250 gram per mole. So the number of moles of R is 1 gram and 250 gram per mole. So it is equal to 1 by 250 mole inverse. Right? This is number of moles of R. So as the molar mass of R and mass of R we know, and we have already calculated the number of moles of R, and from the structure you can see that 1 mole of R can contain 2 moles of Br. From the structure you can see. So what will happen, it can give 2 moles of AgBr after reaction, right? So what can we write? 1 by 250 mole of R can produce 2 by 250 moles of AgBr, right? Now rest of the problem we will solve on top because we are running out of space here, right? So 1 by 250 mole of R can produce 2 by 250 moles of AgBr that we have calculated. Now we have to calculate the molar mass of AgBr. So molar mass of AgBr can easily be calculated by the atomic masses. So for silver it is given as 108 and from bromine it is given as 8. So 108 plus 80 is giving you gram per mole, is giving you 188 gram per mole. Now, if you apply this formula, the number of moles of any substance is equal to mass of that substance divided by the molar mass of that substance. So you can easily calculate the mass of AgBr as 2 by 250 times 188, which is giving you 188 divided by 125. Now if you calculate, it is giving you the mass of AgBr as 1.50 gram. And that is what we are asked to calculate in this problem. So the mass of AgBr that will be produced due to this reaction is 1.50 gram. I hope you have understood this problem. Very interesting and not that difficult. Simple, right? So with that, let's move on to the second one. This has been appeared in Joint Entrance Main Examination 2021. The problem is given below are two statements. One is labeled as assertion A and the other is labeled as reason R. Assertion A is given as treatment of bromine water with propene yields 1 bromopropan 2 ol. And the reason is given as atom of water of bromonium ion follows Markovnikov rule and results in 1 bromopropan 2 ol. In the light of the above statements, choose the most appropriate answer from the options given below. Options are A, both A and R are true, but R is not the correct explanation of A. Option B is A is false, but R is true. Option C is both A and R are true, and R is correct explanation of A. And option D is A is true, but R is false. Now let's see how can we solve this problem. So it has been given that treatment of bromine water with propene yields 1 bromopropan 2 ol. Let's write down the structure of propene first. Then we will consider the reaction and reaction mechanism simultaneously. So CH3CH double bond CH2 is the structure of propene. Now if it is reacting with bromine in the following way, the resulting structure is CH3CH so CH3CH and you can write it down like this Br plus, right? Now we are to consider the Markovnikov addition. So Markovnikov addition considering water molecule to attack in this manner and to break it in this way, right? So if you consider this, you will end up with CH3, CH, CH2Br, and because oxygen has lost the lone pair, so oxygen will come out with a plus sign. So this is the resulting structure. Now if you remove one H plus ion from this one, you will end up with CH3, CH, CH2, Br, and here CHOH. So CH3, CHOH, CH2, Br is the resulting structure after Markovnikov's addition. And this is nothing but our 1 bromopropan 2 ol. So what can we say? Let me just quickly recap the Markovnikov's rule. Markovnikov's rule actually states that any unsymmetrical alkene, for example propene here, if any nucleophilic attack is made, it will add directly to the carbon atom which is associated or attached with the lesser number of hydrogen. So this is Markovnikov's rule, and from this reaction we can easily say that treatment of bromine water with propane is yielding 1-bromo-propan-2-ol, and reason of course is that attack of water of bromonium ion follows Markovnikov's addition rule and results in 1-bromo-propan-2-ol. So we can easily say that both our assertion and the reason are correct or true, and the reason R is correct explanation of A. So from the option you can easily say that option C is the correct option. So both A and R are true, and R is the correct explanation of A. Option C is the right option. So I hope you have understood. Now let's move on to the next one. Problem 3 is taken from Joint Entrance Main Examination 2019, and this is asking to find out the major product from the following reaction. Let's check the mechanism. So because the reaction is carried out in presence of lithium aluminum hydride, you already know that this lithium aluminum hydride can be used to reduce either aldehyde or any ketone group, and this is not actually used to reduce any alkene, right? But here the given compound is although containing double bond, but it is an ester. So we can write down the structure of the given compound in the following manner: CH3CH, double bond CH, C double bond O, OCH. This is an ester. Now if it is reacting with lithium aluminum hydride, it will result in two different alcohols. One is corresponding to the alkyl chain or alkyl group. So it will result in CH3, CH, double bond, CH, CH2, OH, which is known as but 2 in 1-ol. And another alcohol will result in, which is nothing but our methanol. Right. Now we have to find out the major product from the reaction. So we have to focus on the mechanism. So let's write down the mechanism of the reaction. So what is happening here? CH3CH, double bond CH, C double bond O, OCH3. If it is reacting with lithium aluminum hydride, so let me just separate these things out. What will happen? So this bond will break, or it will go in here, and this will go this way. Now, what will result in? CH3CH, and this reaction can be considered as nucleophilic acyl substitution reaction that I hope you have already learned. And this will give you CH3CH, double bond CH, CO minus, Now what will happen? So this will go in this way and this bond will break, right? So this will generate CH3, CH, double bond CH, C double bond OH. This is nothing but an aldehyde containing CH group, right? And this has been broken, so an OCH3 minus would be generated. So this is the product. Now, if you again consider that ALH3 minus will react via nucleophilic addition what will be the product? The product will be CH3, CH, double bond CH, C, O minus, H, H. This is the product. Now if you add H plus and H2O to this reaction, then the primary alcohol will be generated as CH3CH double bond CH CH2OH. So this is the primary alcohol that will be generated due to this reaction of this ester with lithium aluminum hydride, and this is the following mechanism that I have shared with you here. So this is nothing but our butene 1-ol. This is the major product or primary alcohol. So if you check the options, you will get to see that option A is the correct option. So the major product of the following reaction is CH3CH double bond CH CH2OH. Right? I hope you have understood. Now let's move on to the final one. This problem has been taken from Joint Entrance Main Examination 2020. This is asking the correct order of stability for the following alkoxides is 3 alkoxides are given A, B and C, and some options are given. We have to check their stability and we have to find out the correct order. Let's see how can we do that. Now, if you consider this one, the C, it will be the most stable one. Why? Because the negative charge would be delocalized via the following resonating structures that I am going to draw for you right now. So this one can be written in the following manner. O minus CH double bonds CH N and O2 can be written in the following manner. So N plus and here O minus. Right? Now, if you consider the following mechanism, you will have the another resonating structure. So this will generate O double bond CH single bond CH double bond N O minus N plus. So these two resonating structure for this negative charge is delocalized via this following resonating structures for C. So this one is the C is the most stable. Similarly, if you consider the structure A, then you will get to see that no resonance delocalization is possible for this one. So we can consider A as V stable. Now we have to, in order to find out the correct order of stability, we have to consider the structure of B. Again, for B, two resonating structures can be possible. So I'm going to draw it. So O minus C double bond CH2 and NO2 can be written in the following manner. O minus. Right. Also, two resonating structures can be possible here in the following manner. So we end up with O double bond Ce and CH2 minus, and the NO2 below will remain same, exactly similar as we had in the resonating structure 1. Right? But the thing is, this structure on the right hand side will have less contribution. This is not more probable. That's why the stability of B, this is our B and this is our C. So the stability of B, because the right hand side structure is less probable, this structure, the stability of structure B or the compound B is in between A and C. So it is more stable than A but less stable than B. So the correct order of stability would be C is the most stable one and it is greater than, it is more stable than B and B is more stable than. So this is the correct order of stability of the given alkoxides. So if you check the option, you can see that option A is the correct option. So with this I would like to end this session. I hope you have enjoyed this session. And so one reminder that please come and join us for the free demo classes on next Sunday, 18th of June. And people who are not watching right now this live session can go to Aptdemy checklist playlist and you can check the videos. So with this, I'd like to end. Thank you very much for your kind attention. I hope to see you on Sunday on 18 June. Thank you very much. Have a good day. Bye bye.